Hello everybody and welcome back to all my subscribers, and if you're not a subscriber, why not? Right, got a bit of a cold today, so sorry about the voice, but I did want to give an update on my M68K build. So one of the issues that were pointed out in the comments generally tended to be memory, and that is a problem. And when I looked at it deeper, I realized that I did have a number of problems with the control signals for ROM and RAM. Now these are 4 meg chips, but I was only able to address 1 meg of it because I was using the MMIO at a lower range. So I had to fix this because the logic wasn't right. And so what I did was I decided to introduce some NAND gates and memory mapping into this. So let me just show you what I did. So because basically in the chip it was only coming out with Y1, Y0 and Y1 to flip between RAM and ROM. So Y0 was ROM and Y1 was RAM, but that only allowed me to address 1 meg. So what I decided to do was to just use up to 8, 1, 2, 3, 4, 5, 6, 7, 8 as my selector. But of course, to do that with a multiplexer, I would have had to work out how I was going to sort of get 8 but make it the same chip. So what I decided to do in the end was to use NAND gates instead. So if you can imagine, I've got the top bits and I've labeled them A, B, C, and D. When B is 0, then this is sort of 0 to 3, and when it's 1, it's 4 to 7, because if A is 1, then it's 8 basically. So as long as A is 0, right, then I know I'm in the first 8 basically. I'm ignoring C and D because they're just going to be a value. So what I can do here in this case then is I can say so what I did was I used some NAND gates. So I've got the NAND gates. And in this example here, I want not A, right? So the inverse of A into both. And if I want the ROM to be selected, I want not B, okay? And then that will make the ROM chip enable low. And if I want the RAM chip enable to be low, then here I just put in B rather than not B. So if I feed in not B and not A, I get the ROM. And if it's and then if it's not A and then B, I can do the RAM. So basically, this is what I did and rewired the sort of signals. And I'm currently in the process of making all my other MMIO up above that. So if it's 9, for example, it might be GPIO, or upwards from there, basically. So A, blah blah blah. Anyway, so that's what I've done for the ROM and RAM, so that I can basically make sure that I always address all 4 megabits of this. And then I fixed the wiring so that worked, and I went through all of the addresses. I've since got a problem with some of the wires. You won't be able to see this, but basically I had one of the address lines was incorrect, so I've rewired that. The sort of orange wires are my corrections or bodge jobs, and the orange here go into the NAND gate. But there were other hardware setbacks. I got these ZIF sockets thinking, oh, I'll use those to replace the ROM and RAM. Happy days. But I got them in after a long wait from China, and the pins are a bit bent, so they're difficult to get in, but also they're, I don't know if you can see that, they're squared and flat, and they absolutely do not fit into my the holes in the socket, because you know these things are really quite round and very, very snug, and these don't fit in there at all in any way, shape or form. So useless. But the thing that I feared would happen did happen. Whilst pulling this in and out, the pin bent and broke off. Now I've soldered a bit in here just to get it in. It does make an electrical connection, so it does kind of sort of work, but it's not great. So I've had to order some more of those, which is fine. I've ordered some more. They're on the way, and hopefully I'll be able to sort that out quickly. I'm now at the point where I have nothing on the address line, even though A16, which is about here, is actually high. But it's not working the way I think it should work. So let me just tell you that you know, there's been a lot of challenges here with the hardware, and I'm not particularly good with the hardware, but I'm getting there with lots of multimeter usage and a significant amount of time spent with the logic probe trying to work out what's going on, and obviously writing things down. I haven't had as much time as I would like, but I mean, this project is a masterclass in patience and persistence. Like, every step forward comes with a stack full of setbacks. But, you know, I mean, doing this as a learning project, something to teach me things, and it's certainly teaching me things. I'm certainly much better at using a logic probe and a multimeter and an oscilloscope than I used to be. So my immediate focus is obviously going to be on debugging. If I look at the code, this is what's currently in the ROM at the moment. In theory, this is the correct address, because it should point at the top of my 4 megs. And then all I'm trying to do is put visually identifiable pattern into these sort of address, in and out the address register, and the address bus and the data bus, in hopes that I'll be able to see this. So it basically should be writing alternative values back and forth to the ROM. So in theory, this should be flashing away there. In reality, it doesn't. But I'm not 100% sure why. I suspect it's something to do with the hardware. Somebody suggested that the halt needs to be synchronized with the reset. It is, I mean, it was before, and then I changed it to be always high, so that it was never enabled. but I've reset it to use the reset chip, the same as the reset button does. In theory, that should solve that particular problem. I've been thinking about why I started this project, and basically it's about exploring the process of building something from scratch, to understand the details and the hardware and the software. It's not about the end result, it's about the journey. The journey has been very, very bumpy at the moment, and yeah, it's a pretty expensive mistake when you sort of break these things and you have to order stuff from China or get them off eBay or whatever. It's not, these things aren't readily available, most of these chips. So anyway, I would like to hear from you guys if you've had any other challenges, and if you got any tips for sort of debugging sort of stubborn issues like this. What can I do to try and work out what's actually happening between this chip and these ROMs? And it just doesn't seem to be doing anything. But mistakes are part of the process. This is how you learn. Breaking a ROM chip or wiring something wrong, they feel like setbacks, but they're an opportunity to grow and refine my approach and things. I've tried to be gentler with pulling these things out. I've stopped using my fingers. I've long since tried to convert to this sort of puller chip thing to make it come out evenly. I mean, I was using it on that, but that didn't help, because for whatever reason on my hand pulled it too quick or whatever, but it twisted and it just didn't work. So anyway, there you go. So I suppose my message here is really just don't be afraid to make mistakes. Things are going to happen. This isn't a tutorial. This is just me recording the horrible mess that I'm making of this hardware, and learning as I go along. And hopefully one day I will get this thing working. I have considered just buying another board and just starting again from scratch, and rewiring it again, without all this soldering and all this sort of gubbins, now that I've got these sort of wire wrap pins. But yeah, I don't think I'm going to go through all of that. I'll just try and get this fixed and get it working. Anyway, that's the update for me this week. Sorry it was so, no progress, but that's the way it goes sometimes. And thank you very much for your attention. If you do like these sort of things, please like and subscribe and all that good YouTube stuff. And hopefully I will see you next week with better news.